Topic 11, Transformations and Point and Line Symmetry. Preimage, the figure before a transformation. Any picture will do. The image, the figure after a transformation. You'll start with your preimage and transform it. Map, the rules on how a preimage is transformed. In our preimage to image example, the triangle was translated right 6 spaces. We can also write that as x plus 6, comma, y plus 0, because it did not move up or down. Our types of transformations are translation, that is to translate a figure up or down, left or right, without changing its orientation. The slang term is to slide the figure. So we'll take our triangle and slide it. This triangle moved 1, 2, 3, 4, 5, 6 spaces to the right and 1, 2, 3 spaces up. Right is positive and up is positive, so I'll describe this as x plus 6 and y plus 3. We can also reflect. To reflect a figure across a line, creating a mirror image of the preimage. Our slang term will be to flip the figure. Starting with a different triangle, we're going to flip it across our line. When we have a line, we'll count straight down to it. 1, 2, 3, 4, 5. And the same distance down to the line is the same number of spaces we'll count over. 1, 2, 3, 4, 5. We'll do this for every point. We would call this reflection, reflected across the line, y equals x. Lastly, we'll have a rotation, to rotate a figure around a point of rotation. Our slang term will be spinning the figure. We'll start with a triangle, and we will spin it around the origin, rather. So if we imagine one point on the triangle, 3, 3, when it gets rotated 90 degrees, negative 3, positive 3 becomes positive 3, positive 3. It was rotated 90 degrees clockwise. Types of symmetry. There is line symmetry. The line of symmetry is the line which the figure is reflected across so that the image matches up with the preimage. For instance, on your notes you see half of a sun. If this sun figure had line symmetry, then the other half of the sun could be drawn. Notice that the two halves are the same. They were reflected. Point symmetry. A figure is rotated exactly 180 degrees and matches the preimage. For instance, the letter H, when we rotate it 180 degrees, forms the exact same letter. To see another example, I can take a playing card and rotate it 180 degrees to get the exact same picture. Here are some examples. Triangle A prime, B prime, C prime is. That is, we have preimage ABC and image A prime, B prime, C prime, and we want to know how I get from one to the other. Is it F, a translation across the y-axis? G, a 90 degrees clockwise rotation about the origin? H, a reflection across the y-axis? Or J, a reflection across the x-axis? Well, a translation means that it could be slid. We could slide it onto its image. Rotation means we would have to spin it to get it onto its image. A reflection has to be flipped, and again we see reflection, which means to flip. So I'm going to imagine this triangle, A in the left-hand corner, B in the right-hand corner, and C in the bottom. I can see that if I just slide it onto the image, it's the exact same thing. A lines up with A, B lines up with B, and C lines up with B. Also, it slid across the y-axis, which matches F perfectly. It was a translation, it slid across the y-axis. F is my solution. The polygon A', B', C', D', E' is a translation, a slide across the x-axis, a 100 degrees clockwise rotation about the origin, or a reflection across the y-axis, a reflection across the x-axis. So, to start with my preimage, A, B, C, D, E, let's see if it is a translation across the x-axis. So we'll take our shape and slide it down, and it just does not match up perfectly. So it cannot be a translation. Let's check a 180 degree clockwise rotation about the origin. So we'll still take our A, B, C, D, E, and now we're going to rotate it 90 degrees, and then we'll rotate it another 90 degrees to get our total 180 degree rotation. This does not match our image, so it cannot be our solution. Let's check C and D. So either it's going to be a reflection across the y-axis, or it'll be a reflection across the x-axis. Because my figure is below it across the x-axis, I'm pretty sure that's where my reflection will be. But let's check. So I'll reflect my shape, and it matches perfectly when it goes across the x-axis. So my solution is that preimage A, B, C, D, E gets reflected across the x-axis. For the following images, determine whether the image has point symmetry, that is, I can turn it upside down and it is the same. Line symmetry, I can draw a line and the two pieces are identical, they're reflected, or if it has both point and line symmetry. Otherwise, it will have no symmetry. So starting with my arrow, I see that I can draw a line of symmetry. The top half could be reflected across the line to create the bottom half. So it does have line symmetry. When I rotate my figure 180 degrees, I see that it does not match up perfectly, so it has no point symmetry. For the next shape, when I draw the line, I see that that top half is not reflected onto the bottom half. It does not have line symmetry. Try a couple other lines. See if you can fold it to have a reflected line. When I take the same shape and rotate it 180 degrees, that is, I turn it upside down, it is the exact same shape, so it does have point symmetry. For my last shape, there is no line that I can draw where this shape will be perfectly reflected. And when I rotate it, it is not exactly the same, so it does not have point symmetry. The last shape will have no symmetry.